Okay. Hello, everyone. Welcome to Commerce Coordinator, connecting open edX with commerce. My name is Glenn Martin. I am the principal software engineer on the purchase squad. You can catch me on Slack via my 2U short name, but on GitHub, I include my middle initial.
Hi, everybody. I'm Phil, and you can see my contact information there. I work with Glenn.
Sorry. E-commerce has been on a long journey in the Open edX project. As a community, we need to figure out where to go next. Currently, we're working on a solution called the Commerce Coordinator. It is meant to be a request router and transformer. You can see our slides at the conference from last year. So what have we been up to? Well, we actually got sidetracked because there was a pressing need to migrate to another payment processor for our company, 2U. So we had to finish that up. And the advantage is that Stripe is now available as a payment processor on Master, and we're hoping to see it in Palm. Please check the release notes if you haven't already. But right now, we're back on the e-commerce deprecation and replacement project. While e-commerce in its current form is going away, we have received good feedback that we need to simplify the coordinator and are thinking critically on how to do so. To be completely honest, we don't have an exact answer right now in terms of how the Commerce Coordinator is going to be simpler or how it could meet everyone's needs. But we want to give it a shot at showing briefly what we have so far, what a typical flow in the coordinator might look like. So let's start with an example, fulfillment. The idea behind fulfillment is that when a user pays for a course, the operator needs to give the user access to the course they have paid for. We call that action fulfillment. Others may call it enrollment. Let's work backwards, starting with our goal. In our LMS, we have an API endpoints that allow a user for an external system to place a user in a course. You can see that this code is reaching out to an endpoint and sending a JSON object called enrollment_data. Wait, okay. Here's what enrollment data looks like. You can see it's just a dictionary with information about how we want to do the fulfillment. We send enrollment data from a celery task. It's very simple. This is literally a copy and paste of what we have in our code right now. This celery task allows us to queue up the request for fulfillment. Why? We needed to add this because as a larger operator, we have a lot of fulfillment requests, and historically, this fulfillment endpoint has been very slow for us. How do we solve this? We've had a need of some sort of asynchronous queue to do this fulfillment, so our e-commerce servers do not stall other requests while waiting for fulfillment. And this configuration is in settings/base.py. It configures Coordinator to create a task to fulfill a course every time our backend system set 2U requests a fulfillment. I think this is the heart of the versatility of the Coordinator. As long as you fire a signal with the right parameters, any app in the Coordinator can trigger fulfillment. Here's a bit of code, but it's mainly a signal receiver. So, yeah. Finally, we have a view. This is where our backend systems at 2U reach out to request fulfillment of a source. All we do is get those parameters that we plug into the enrollment_data dictionary, validate that those are the same values, and then send the signal. We don't mean to be mysterious about our backend systems. It's basically software, like what our e-commerce repo currently uses, which is Django Oscar. But instead, it's Ruby, and it's called Spree. Let's not worry about that entirely here. Just imagine your backend system is able to reach out to an endpoint inside Coordinator.
All right, so working backwards then. So we will now step through this, right, from the perspective of an actual request. And that's when our backend system, and we're basically going to repeat all the slides you just saw, but it's when our backend system reaches out to order fulfill view, which you see here, with all of the parameters of the course and user that it'd like to fulfill. In our settings, when this signal over here, fulfill order place signal, you see in blue at the bottom of the slide is called, it looks to the configuration and sees that when that signal is called, we have configured it so that that signal is sent to the LMS, and specifically calls a signal called fulfill order place send enroll in course. That's picked up by this task, and that task inserts the data that was sent by our backend system into this enrollment data JSON structure, which we saw earlier, and that is sent to the LMS as a, or essentially once that task runs, right, once it's queued up, right, LMS is, or will receive that fulfillment data from the coordinator. So this is the general pattern that the coordinator is doing. Okay, so why might this be a good idea? 3 reasons I'd like to suggest. One is we have a place to work together as a community on e-commerce using a single framework and language. 2, you, are migrating the parts of e-commerce e-commerce that we use to the coordinator. We happen to use a lot of e-commerce because we developed a lot of it over the years. And maybe the community can use that work in some form, whether it's running the coordinator in production or using the coordinator as a reference implementation for for their own code. But the hope is that somehow the community will be able to use this work and generalize this to their own systems. A lot of us have the same problem. The third factor of why this might be a good idea is a lot of us have the same problems. Where do we run the custom code we need for selling our courses? And Coordinator provides a place for that code to run. But we know our solution is overly complicated. We met back in July and we got a really clear message that the coordinator is too much overhead for most operators. We're trying to think of ways to simplify this architecture. Internally, we need the coordinator at 2U because 1, we can't put our code in LMS. Open source wouldn't accept code that only applies to us. And 2, we don't want to reinvent in Ruby, right? We could call the LMS, our LMS directly from our Ruby internal backend, but this would require reinventing a lot of Python libraries we've already made in the Open edX world in Ruby. So Coordinator lets us put this logic into Python and transform the incoming request into the right shape, so we can fire the request into the open source world. It becomes a sort of transition world between closed source, which is very particular to us and only us as an operator, and open source, which is generalizable to everybody. But not everybody will be able to use, or not everybody needs what we need, right? One example is infrastructure. Not everybody needs Redis and a Celery queue. So what we're up to now is doing a lot of documentation. We're doing a lot of work to try to understand what exactly e-commerce does and reorganize the parts that we use into the coordinator so that it's more organized and systematic. Because we're drowning in documentation, we also hope to make tooling to auto-generate runtime diagrams, like the one you see in yellow here. It's a little hard to see, but we hope that diagrams like these will make it easy for folks to understand, okay, my setup of the coordinator allows either the legacy e-commerce service to call the fulfillment endpoint, or the backend service that another service called Spree, right, to call the fulfillment endpoint. And we've been sharing all of this information with T-Curl so it can help inform their projects as we together try to advance the state of Open edX e-commerce with the community. So where do we go from here? Honestly, we don't know the answer to that. But if we were to perform a little bit of divination, here's what we can see from our vantage point. And others might have additional thoughts as well. For smaller operators, T-Curl is funding a really cool discovery project that is looking into wiring WooCommerce with Open edX and making that really easy to set up. So that's really exciting work. It's a kind of blended development model. So if you're a smaller operator and you're interested in WooCommerce, definitely take a look at that project. We're trying our best to help with it. Like we mentioned earlier, we are sharing our R&D with T-Curl and actually met a team looking into that work, and we're talking shop with them just last night. If you operate any sort of system running Django Oscar e-commerce with Open edX, or if you are a larger operator interested in selling courses using Open edX software, please come talk to us, because the message we've gotten so far is that there are not a lot of folks out there interested in the scale we're working with right now. And this leads to a really important question. How do we work together on this? We need some vision casting. We don't know the answer to these questions. They are open questions, but I would definitely challenge everybody to think about these things. E-commerce is naturally a difficult area to collaborate on because it touches the revenue model of all of our organizations, but I think it's possible. I have a glimmer of hope that there are awesome things in the e-commerce world that we can work on together. All right, that's it. Lots of links here. Wanted to quickly highlight two things. None of our code is a secret right now, so please check out the 2U Project Theseus branch in the GitHub Commerce Coordinator repos. Links to on the Confluence page to that repo. And please join us at the e-commerce Next Steps update on April 26th. We'd love to hear your thoughts. Thank you so much.